Hey guys, I am going to go ahead and record myself reading our article for this week's homework, Engineering the Next Step in Space. My recommendation is to go ahead and read along with me while you listen. Jamal Taylor has been interested in space travel since he was just a boy. His interest led him to study aeronautical engineering in college. Studying hard helped him to get an internship at New Space Technologies. Jamal is working hand in hand with the Space Division engineers there to develop the next generation of spacesuits. The spacesuits that astronauts use were designed to be worn in the harsh conditions of outer space, where they are subjected to extreme temperatures during spacewalks. If an astronaut's back is in the sun, the spacesuit must provide protection from a temperature difference of as much as 135 degrees Celsius between the front and the back. The spacesuit must also protect from the near vacuum of space by providing both life-saving oxygen and the pressure required to keep the human body from exploding. The spacesuit's primary function is to let astronauts work safely as they make observations and repair and make modifications to space vehicles. Spacesuits were designed with mobility in the upper body, since astronauts move themselves using their arms, and a more rigid lower body for stability. NASA asked that the new space technology team to reevaluate the current spacesuit and determine how it could be modified for NASA's new mission to explore the moon and eventually Mars. NASA gave the company information on the environmental extremes the suits would need to protect astronauts against as they work on the surface of a planet. Jamal's team found that the suit needed greater mobility. Astronauts on a planet's surface need the ability to easily move their upper and lower body. The team divided the project into manageable parts, redesigned the upper body system, redesign the lower body system, and redesign of the helmet, gloves, and shoes. The team's goal was to design a complete spacesuit that was lighter and easier to work in than the spacesuit that astronauts are currently using. Jamal was tasked with working on a redesign of the shoe. He saw that the spacesuit shoe was actually made of three parts: the sole, the upper body, and the overshoe. Jamal established his design goal, decreasing the overall weight of the shoe and eliminating the need for the overshoe. The design also had to protect against the extremes of temperature, the near vacuum on the moon, and the reduced atmosphere of Mars. The design goal also included protection against punctures because the shoe would now be used on the rocky surface of the planet. He reasoned that new materials and technologies should allow him to meet his goals. Jamal divided his research into three parts. First, he would test the upper body of the shoe, then the sole, and finally, the complete shoe. Scaled models would be used in all tests. All three phases of testing would be subjected to temperature extremes to mimic the environments the shoes would be worn in. The material's strength, flexibility, resistance to tear or punctures, ability to insulate, and durability would be examined. Jamal remembered studying composite materials. These are made from two or more materials, and when layered together, their properties are different from the individual materials. The composite materials Jamal identified were stronger, lighter, and less expensive compared to traditional materials. After reviewing the characteristics of the new composite materials, Jamal determined that the upper body would need to be made from one of the fabrics, and the sole would need to be made using one of the thicker, denser composite materials. However, none of the materials would protect the feet from frostbite or burns. Jamal was faced with his first engineering challenge, since no material that met the temperature requirements would provide enough insulation. He decided to use a layered upper body, an insulating material between the inner layer of spandex, a kind of stretchy fabric, and an outer layer of composite fabric. In his models, Jamal used combinations of the best composite fabrics and insulating materials with spandex in between. The models were placed in an environment chamber that would simulate the extreme temperature, atmosphere, and gravity of the moon and Mars. Jamal's measurements of each model's strength, flexibility, resistance to tear puncture, ability to insulate, durability, and reaction to temperature variations were recorded. Jamal followed the same basic design with the sole. For the sole, he decided to put the insulating material between the layers of composite material. The testing models were constructed and tested using the same setup as the fabric tests. Using his test results, Jamal had scaled models of spacesuit shoes manufactured with combinations of the best three fabrics and composite materials. To test the different materials under conditions that would mimic the environments on the moon and Mars, a treadmill was placed in an environment chamber that would simulate the temperature, atmosphere, and gravity of both. Using a mechanical foot to simulate walking and then recording the movements, Jamal discovered that the motion was not like walking on Earth. The current spacesuit shoe used by astronauts to walk on the moon in the Apollo missions was hard-soled. The hard sole required astronauts to use a jumping motion to move. But walking on a planetary surface isn't the same. The sole needs to let astronauts walk much like they would walk here on Earth. Jamal thought about his hiking boots with their combination of flexibility and stiffness in the sole. He decided to redesign his shoe models using soles made from combination of materials with different amounts of stiffness. Retesting the new models, Jamal was surprised that the sole design used in his hiking boots was the best design for astronaut shoes as well. Jamal began to prepare the presentation for his team. He realized that after looking at all the test results, he couldn't choose a best design. Several of his final models met the requirements he set himself. There wasn't one design that was clearly the best. Jamal would need to present the best designs for further engineering review and testing. After his presentation, Jamal was asked about the engineering skills he developed or the realizations that he had that he could share with his peers back at college. Jamal said that he had a better appreciation for the design process. It involved research, decision making, designing appropriate models, testing, and analyzing the test results. The simple tests he conducted in his classes didn't prepare him for the complexity and scale of the testing needed to design an object or what to do when the testing failed. The real-world design process can be stressful. Large projects have deadlines that need to be met. Jamal realized that he could summarize all of this in one sentence. Learn as much as you can in school, but take every opportunity to use your knowledge outside of the classroom. Okay, guys, go ahead and answer the questions that follow about this article, and I will see you in class.